So in the last lecture, we discussed the Poisson integral formula, so which is very important, expected for examination. So what is the statement of Poisson integral formula? If f of z is analytic function within and on a circle C, modulus of z equal to r, and if alpha is any point within the circle, then it satisfies this equation, which is equation number 1. Similarly, from this we can deduce the f of r e raised to power iota theta, which is equal to 1 by 2 pi 0 to 2 pi r square minus small r square f of r e raised to power iota phi into d phi over r square minus 2 capital R into small r cos of theta minus phi plus r square. So what is so from in this where alpha is equal to r e raised to power iota theta is any point in the circle which is C such that modulus of z which is equal to r. Modulus of z which is equal to r. Now proof of this theorem. So in order to prove this theorem, first understand the definition of inverse of a point, the inverse point with respect to circle. Now first understand the definition inverse point with respect to circle. So what is the inverse point? Inverse points are 2 points, point P and Q are said to be inverse point with respect to circle C, with respect to circle, with radius, with the center O and radius R if OPQR, if O, P and Q are collinear means which acts along a straight line, and OP, OQ, this is equal to R square. So this is a definition of inverse point. So we will use this definition in this theorem. So first understand the definition of inverse of 2 points with respect to circle. Now, suppose in the given part, the circle is, so this is a y-axis, this is a x-axis, and So this is a given circle. Given circle, and this point is origin, and this is some straight line. This is a radius of a circle, capital R, and this is a origin. This is a point P whose coordinate are alpha, that is inside the circle, and this is point Q, which is a inverse point. P and Q are inverse point with respect to circle. Then the point Q is outside the circle and its coordinate are r square over alpha conjugate. So remember that P and Q are inverse point with respect to circle. P point is inside the circle and Q point is outside the circle. So what we get? We get alpha, which is equal to r e raised to power iota theta, not phi, iota theta, be any point inside the circle, be any point inside the circle. This is, and clearly, if I take this OP distance, which is R from this, then clearly 0 less than R less than capital R, because this point is inside this values. Now what is inverse of point P of alpha? This is point with respect to circle C is Q and its coordinate are r square by alpha conjugate. So this is find from the result OP into OQ, which is equal to r square. So this is find from this values. So this is equal to r square OP OQ, which is equal to r square, and coordinate of Q is this value, which is equal to r square by alpha conjugate. So remember that result. Now this point is inside the circle, then it means function is not analytic at this point. So here we will apply the Cauchy integral formula. So by Cauchy integral formula, since f of z is analytic, so this formula implies f of alpha, which is equal to 1 by 2 pi iota around circle this f of z into dz over z minus alpha. So this is by Cauchy integral formula. On the same line of action, Now this fz, since Q point is outside the C, then f of z is analytic in C, and this point r square by alpha conjugate is outside the C, then f of z over z minus r square by alpha. This is analytic in C, because this point is outside the circle. Then by Cauchy theorem, so by Cauchy theorem, integration around f of z over z minus r square by alpha conjugate into dz around C is equal to 0. So this is equation number 2. Now subtracting equation number 2 from 1, so we get f of alpha minus 0, which is equal to, here it is also written as this value, also written as 1 by 2 pi iota into C fz into z minus r square by alpha conjugate is also equal to 0. So this is equation number 2. Now from this 1 by 2 pi iota is taken outside. So this is a C, around C, this values, and this value is first 1 by z minus alpha minus 1 by z minus r square by alpha conjugate, this value, into fz into dz, this values. So simplify this result, it implies f of alpha, which is equal to 1 by 2 pi iota around integration C. This value is equal to alpha into alpha conjugate minus r square into f of z into dz over z minus alpha into alpha conjugate z minus r square. So we get this value. So this can be written as f of alpha, which is equal to 1 by 2 pi iota around C. This, if I take r square first minus alpha into alpha conjugate f of z into dz over z minus alpha into r square minus alpha conjugate z, this value, and this is equation number 3. So which is a Poisson integral formula. Now deduction from this formula, as we know that as we know that modulus of z, which is equal to r, so it implies z is equal to of this kind, e raised to power iota phi, and it implies dz, which is equal to r e raised to power iota phi into iota into d phi. This values. Also, what about alpha? Alpha is small r e raised to power iota theta, and it implies alpha conjugate, which is small r e raised to power minus iota theta. So alpha into alpha conjugate. So we required this result. This will be r square, small r square. So alpha also, alpha conjugate, this will be small r square from this. Now second requirement is r square minus alpha conjugate into z, this values. So this value from this r square minus alpha conjugate. So this value is r square minus small r square. So this values. And next requirement is r square minus alpha conjugate z. So what is r square? R square is this minus alpha conjugate. So what is alpha conjugate is r e the power minus iota theta into z. So what is z? Z is capital R e the power iota phi. So this can be written as r square minus small r e raised to power iota, and this is phi minus theta. So this is phi minus theta. R square minus alpha conjugate z. Now from z minus alpha, so z minus alpha, which is into r square minus alpha conjugate z. So just substitute the values. Z is capital R e raised to power capital R e raised to power iota phi minus small r e raised to power iota theta, and this is r square minus small r capital R e raised to power iota phi minus theta, this values. So I take from this e raised to power iota phi common, and from this r, so we get r into e raised to power iota phi. Now from this we get r minus small r e raised to power iota theta minus phi, here phi minus theta. So here it is r minus small r e raised to power minus iota theta minus phi. So this can be written as minus 1. So from this, what is the value of r e raised to power iota phi? So this is a z. So we may write again in this way, r e the power iota phi, and this value is r square. This is r square plus small r square minus 2r, this into this and this. So small r into capital R bracket e raised to power iota theta minus phi plus e raised to power minus iota theta minus phi. So this can be written as 2 times cos of angle. So this value will become r e raised to power iota phi r square plus small r square minus 2 r cos of theta minus phi. Also, we may written that cos of phi minus theta, because cos minus theta is equal to cos of theta. So we can use any values. Now this value, now dz, now substitute all the values. So we get f of r e raised to power iota theta, and this is equal to 1 by 2 pi iota. So integration, which is 0 to 2 pi, because phi varying from 0 to 2 pi, this values, and this value is capital R minus small r, this value, into f of capital R e raised to power iota phi into r e raised to power iota phi into iota into d phi. So this iota is cancelled with this iota over this values, which is equal to r e raised to power iota phi, and this is r square plus small r square minus 2r capital R cos of theta minus phi, this value. So this term is cancelled with this term. So we get the required result, so which is equal to 1 by 2 pi integration 0 to 2 pi into r square minus small r f of r e raised to power iota phi into d phi over r square plus small r square minus 2r r cos of theta minus phi. So this is our result. This is the deduction from the Poisson integral formula. Now after using this result, the next example is, question is, using the Poisson integral formula, Poisson integral formula, using this formula for a circle, for a circle, show that what is the statement? Integration 0 to 2 pi and e raised to power cos phi cos of sin phi into d phi over 5 minus 4 times cos of theta minus phi. This value is equal to 2 pi by 3 e raised to power cos theta and cos of sin theta. So this is my question. This is very important result. So that is application of Poisson formula. So how we will solve this result? So first, what is the statement of Poisson formula? So just write solution of this result. So what is the statement? Statement of Poisson formula, which is equal to f of r e raised to power iota theta. This is equal to 1 by 2 pi integration 0 to 2 pi this value capital R square minus R square f of r e raised to power iota phi into d phi over R square plus R square minus 2RR cos of theta minus phi. So this is a statement of Poisson formula. Now just compare that from this question. So when we compare this result, so from this r square plus small r square, which is equal to 5, and minus 2r into small r, which is equal to 4. So just comparing that, r square plus small r square, which is equal to 5, and small r into r, which is equal to 2. If it is equal to 2, so from this r square plus, when we substitute the value of small r, 4 by r square, which is equal to 5, and this value can be written as r raised to power 4 minus 5r square plus 4 equal to 0. So from this, it is a quadratic in r square. So this can be written as r square minus 1 r square minus 4, since radius is always positive. So it has r is equal to 1 and 4. So r is equal to 1 and 4. This is possible only radius is positive. Now first let capital R, which is equal to R has 1 and 2. Sorry, this is 1 and 2. If R is 2, then small r is equal to 1. So this is from this equation. Similarly, if r is 1, then small r is equal to 2. So this is from this equation. So in this case, r is greater than capital R, so which is not possible because 0 less than small r less than r. So we take this values. We did not take this values because it does not satisfy this condition. Now from this capital R equal to 2 and small r is equal to r, so just substitute the values. Now when we substitute the values, what we get? So first is f of r e raised to power iota phi. So what is capital R? F of 2 e raised to power iota phi. So substitute the value of r. So what is given? So this is given as e raised to power cos phi on comparing and cos of sin phi. This values, then it implies functional value of small r e raised to power iota theta. So just replace phi by theta, e raised to power cos theta and cos of sine of theta. So this value, we get the function value of these values. So it implies e raised to power cos of theta, cos of sine of theta, and this is equal to 1 by 2 pi integration 0 to 2 pi, which is 3 times e raised to power cos phi cos of sin phi into d phi over 5 minus 4 cos of theta minus phi. So which prove our result. Now from this integration, when we shifted this value on this side 2 by this values, so what we get? We get this is 3 times, and when we shifted this values, so it implies integration 0 to 2 pi. So this is e raised to power cos phi cos of sin phi d phi over 5 minus 4 cos of theta minus phi, which is equal to 2 pi over 3 e raised to power cos theta cos of sine of theta. So which prove our result. So in this way we can find the value of integration by using the Poisson integral formula. Now next, do yourself the statement of the question is, if f of s which is equal to integration of c 4s square minus 3z plus 1 over z minus s raised to power 2 into dz. What is C? C is a circle with modulus of z which is equal to 3. So our statement is find f of iota, number 1. Number 2, find f of 1 plus iota, f of 1 plus iota. So here we will use the Cauchy integral formula. Cauchy integral formula to find the integration, to find its value. So this is by using the Cauchy integral formula. So do it yourself. In the next theorem, in the next lecture, we will discuss the converse of Cauchy theorem.